Hello and welcome to Chapter 9, Day 10 Notes. We're going to talk about solving systems of equations. And we'll also talk about writing equations of hyperbolas and parabolas, our last couple of conic sections. So we're going to start by doing a couple more solving systems of quadratics. All right, so let's take a look at that first example, and our number one goal is to see if we can first identify what kind of equations we're dealing with. So let's take a look. So if we take a look at these first two equations, we have 5x squared plus 16y squared plus 10x minus 64y equals 75. And hopefully you can recognize that this is what type of conic section. So when you're trying to identify, you look at your quadratic coefficients and you compare them. You compare their signs, you compare their values. So I notice they are the same sign, both positive, but they are different values. So hopefully you're able to recognize that this first conic section is an ellipse. And what about this second one? Now, it's not necessarily a conic section, but this is something that you've been dealing with since day one, essentially. All right, so hopefully you recognize that this is a linear function, and that's in standard form. So as we're looking at these guys, that's number one, is identify what we're dealing with. So we have ourselves an ellipse and we have ourselves a line. Now, we talked about elimination last time we solved these types of systems, but if we tried to use elimination this time, it's not really going to work because we've got multiple variables here. So what we need to do is we need to use substitution. So if I just look at this second equation here, and I solve for x. So I'm gonna already have my work shown, so if at any point you need to pause the video, please do so. All right, so we're gonna use substitution. So we have x by itself, and we're going to substitute in for every x in the ellipse equation. So when we do that, and we get through some of the algebra, okay, so we first substitute in, all right, for the x's. Now I'm going to FOIL this guy, and that's where we get this 16y squared minus 8y plus 1. Squaring the 5 gets us to 25. However, we can simplify 5 over 25. That just becomes 1 over 5, okay? Distributing the 10 to this guy, we can do 10 divided by 5, and that's where we get the 2 times that quantity. So we're just going to continue to clean this portion up, which is here, okay? And now I notice we still have this denominator, so let's try to eliminate those. Those aren't necessarily easy to work with when we have fractions. So what we can do is if we multiply everything through by 5, this denominator will cancel. 5 divided by 5 goes away, all right? And then we're going to distribute that 5 to each of these terms that remain, okay? So when we do that, it's going to clean up to this guy up here, okay? So now we're at 16y squared minus 8y plus 1. We distributed the 5 to each of those other terms, okay? And we cleaned them up, setting it equal to 0 because we notice we've got ourselves a quadratic. The good news is everything is divisible by 96. So divide everything through by 96, and we've got a nice quadratic here that we can factor. So we factor it as y minus 4, y plus 2, okay, and we get our two answers. But we get our y values, so we know we need to solve for our x values. So we just substitute back. I substituted back into the linear function, that second equation. So when y was 4, we got x to be 3. So remember, we write our answer as the ordered pair. When y is negative 1, we got x to be negative 1. So there are the two ordered pairs between our ellipse and our line. Makes sense that we only have two intersections. Let's take a look at the next example. Okay, can we identify what two types of equations we're dealing with? All right, so if I take a look at this first one, remember we first start looking at our quadratic coefficients. I notice the signs are opposite. That right there tells us it's got to be a hyperbola, okay? Now this one we may not recognize in this format, but what if I rewrote it as x equals negative 24y, or we could have also thought about it as y equals negative 24 over x. Now, we're not going to deal with it in this sense, just because it's going to be easier when we substitute. But hopefully you recognize that this guy is a rational function, which we just finished graphing in the last chapter, okay? All right, so we've got ourselves a hyperbola and a rational function. Again, we can't use elimination like we did the last round of this section, so we need to use substitution. I thought it would be easier to substitute for x since there's really nothing else going on besides squaring x, okay? So we're gonna go ahead and substitute. So we've isolated x and we're gonna substitute into our hyperbola, all right? So there is kind of a lot going on, so just again, if you need to pause, pause when you need to. So we're gonna plug in negative 24 over y, we're gonna square it, okay? When we do, we get 576 over y squared. Just like before, we have our fraction, right? So to eliminate that, we can multiply everything through by y squared. When we do that, these guys will cancel, right? But we have to remember to then distribute that y squared to the other two terms. So when we do, hang on one second, all right, when we do that, now everything through here, okay, is nicer, right? So we have a y to the fourth. Okay, so what are we going to do with that? Well, let's bring everything over to the right-hand side to keep that coefficient positive, okay? So it looks like this. So this is what we call quadratic-like. It's almost like y squared minus, or I should say 5y squared minus 44y minus 576 equals 0, right? So we can still think, all right, let's see if we can factor this. Two numbers whose product is 5 times negative 576 and whose sum is negative 44, okay? The only thing is when we do that and we figure out those two values, they're going to be in terms of y squared. So if you're using your calculator, all right, and you say, okay, well, what are those two numbers that multiply to 5 times negative 576, but add to negative 44? Hey, lo and behold, we have these two values here, negative 80 and 36, okay? But notice they are both y squared. So now we're just going to group them, right? First 2, second 2. And when we continue on, we'll end up with our two factors. 5y squared plus 36, y squared minus 16. Now, hopefully you recognize we can factor this further to y plus 4, y minus 4, okay? So now we need to solve. So we set each of these equal to 0, right? Well, when we set 5y squared plus 36 equal to 0, we end up with y squared equaling negative 36 over 5. Well, there's no way that we can take a number, square it, and get a negative. So we throw this one away. This is extraneous. When we focus our attention over here, we get our two y values, y equals negative 4 and y equals positive 4. And now our last thing that we need to do is plug in to find our x values that go along with it. All right, so when y equals negative 4, we can plug into the rational portion and we get x to be 6. So here's that ordered pair. When y is 4, we get x to be negative 6. So again, we have two intersections. All right, so these are a little bit more involved. You just have to be very careful with your algebra. Okay, but if you have questions, let me know. Let's continue on and looking at writing equations of hyperbolas and parabolas. Okay, let's start with hyperbolas. Okay, so a few reminders here with hyperbolas is just off to the side, right? Here are the two versions of hyperbolas. When the x quantity is positive, we're going to open in the x direction, meaning left and right. When the y is positive, that means our hyperbola is opening up and down. So these are things we have to remember, okay? The transverse axis is based on whichever term is positive, okay? The vertices and foci lie on the transverse axis. Remember, we talked about T, V, right? Transverse axis goes with the vertices. And then the length of the transverse axis is the distance from the vertex to vertex, and the conjugate axis is the other guy. So let's zoom in and take a look at this first example, see what we got. Okay, so we are told that we have vertices at 2, 6, and 2, 12. So we have one vertex at 2, 6, the other at 2, 12. So hopefully with this, you can recognize which direction we're going to open. Because they're vertically aligned, that means our hyperbola is going to open up and down. So it's going to be opening in the y direction. So since it's opening in the y direction, that means y is positive, okay? So kind of keeping that in mind. So if we think about that, we could go ahead then and find some other pieces of information, okay? We can say the midpoint is going to be, the midpoint of our vertices will give us our center, okay? So we get our center to be 2, 9, okay? Now, we're also given the length of the conjugate axis. So we'll think about that in a second. Remember, the conjugate axis is the other guy. The other thing we can think about is the distance from our center to a vertex. Well, that's going to be our y radius, and we should be able to just count that, okay? Our y radius is going to be, what, 3, it looks like? Okay, so our y radius is 3. This conjugate axis here is the other guy. So that guy is going in this direction. So that's going to help us find our x radius. Okay, so we're going to take the length of that conjugate axis, divide it by 2, and that's where we have our x radius of 8. So we have that information, and I know that this guy opens up and down. So again, that means our y value is positive. Okay, so now we just plug in. We have our center, 2, 9. X radius was 8. We said our y radius was 3. So now we plug in, and we have our equation. Negative x minus 2 squared all over 64 plus y minus 9 squared all over 9 equals 1. All right, let's take a look at the next example. Okay, as we take a look here, we're given our foci of -4, -4. So here's one of them, and another one at 6, -4. So here we are. Now, one thing I note is that they are horizontally aligned. So which direction is our hyperbola going to open? Hopefully we recognize it's going to open left and right. So it's going to look something like this. Okay, notice I didn't pass through the foci because the foci are inside of the openings, right? Inside the mouths. But we can go ahead and find our center by taking the midpoint of the foci. So we get our center to be 1, -4. Okay? So another thing we should recognize is this distance, that's our F value, right? So from 1, -4 to one of the foci, right, to one focus, we're going to get that F value to be 5, okay? Now, the transverse axis, this is our main axis. So our transverse axis is going to go from vertex to vertex, okay? So that's going to be our x radius, that guy right there, all right? So we can take that transverse axis, divide it by 2, and we're able to get our x radius. But now we have to use that F value to get the y radius because we don't have enough information other than what we have. So we need to do a little bit more work, okay? So remember with hyperbolas, the F value is equal to the square root of Rx squared plus Ry squared. So we know what our F value is, 5. That was the distance from our center to one focus. And we know our x radius is 4, so when we square that, we get 16. So squaring both sides, 25 equals what's left underneath. And all I have to do is solve for r squared, or Ry squared, sorry. So we get our y radius to be 9. Now, since it opens left and right, we know x is going to be positive, okay? So as we're continuing on, since we know x is positive, since it opens left and right, all we have to do is remember which one's positive, which one's negative, and we can plug in the pieces. We know our center is 1, -4. We know our x radius is 4, so we square it. Our y radius is 3. or ry squared is 9, right? We found that, so our y radius is 3. And now we go ahead, we plug our in to get our equation, okay? All right, let's take one look at parabolas, and then we'll go from there. Okay, so parabolas. Actually, I want to scooch over here, okay? Parabolas. The thing we have to remember with parabolas is there are two ways to write our equation. It depends which direction it's opening, and that determines which variable is being squared. If x is being squared, we're going to open up or down, right? And we're going to open up if p is positive and down if p is negative, okay? Now, if y is being squared, that means we open left or right. We open left if p is negative, and we open right if p is positive. Okay, so keep that in mind. We need to know which direction it opens, and that's going to go ahead and tell us which equation we're going to plug into. So let's take a look over here. Okay, we are given our vertex, so we plot that 1, 4. And we are given our directrix. It's this line, x equals 6, right? Now, I know since our directrix is to the right of my vertex, that means we have to be opening to the left. My directrix will never touch the parabola, okay? I also know that the distance between our vertex and where our directrix is located is the absolute value of p, okay? So, a few things, all right? Because it opens to the left, I know y is squared, okay? So, I'm keeping that in mind. Now, also, because it opens to the left, we know p is negative, okay? So then, this distance here is going to be the absolute value of p, and the absolute value of p is 5, but because we know p is negative, p must be equal to -5, okay? So, remember, we have our vertex, and our vertex is the point HK, which in this case is 1, 4, all right? So remember, the order is important, okay? So we are dealing with this equation right here, all right? So our k value goes with y, the h value goes with x. So we have y minus 4 squared equals 4 times our p, so 4 times -5 is -20, and then our x minus h is x minus 1, okay? I want you to try this last one on your own, and we will check in with each other next time we see each other, all right? Have a good day. Bye.